Welcome everyone to this next section of the analog basis track. We are joined with Marco Romero and
Vimbo Samanga.
yeah, sorry about that. Ruvimbo Samanga, and they're going to be speaking about the construction of a Namoga research station in the Namibe Desert by transforming a bluebird carcass into one of the NOS on the International Space Station. Thank you for joining us, guys. Take it away.
Thank you very much to the Mars Society, Danielle, for this brief introduction. So today, as Danielle will explain, we will talk a little bit about our ambition and the path we want to develop to bring to the Angolan desert what we call the first step of our analog research station, starting by the habitability issues that brought us here and that we are trying to tackle, the problems we are trying to tackle, the background and reference we are using to develop this kind of system, the framework of the astrobus itself, and then bring our expertise as space lawyer, space system engineer, and project manager to build this analog and then solve the habitability issues here on Earth. So far, we know that either Angola and either Zimbabwe had a lot of issues when regards to disaster management. A lot of houses uh, are, are damaged every single year by cyclones, floods, and other natural disasters. Um, we have a very huge example of the Zimbabwean disaster of the cyclone Idai that affected not only Zimbabwe, Mozambique, and Angola also had some of the floods issues from other different causes. And then we need not only a faster response, a robust response, and a sustainable response to those habitability issues. And we foreseen on space industry the same issue of developing habitability on very extreme conditions like Mars, Moon, and other celestial bodies. And the market is is growing a lot that we see that um, we have several companies challenge like Space Factory, Mars One, bringing together solutions for inflatable, underground, pre-built 3D printed habitats. The fundraising or the way those missions are economically feasible. They are thanks to the right share and the different business model than the standard space exploration. And we have scheduled and developed until now several missions to Mars. And Africa, although is a little bit behind on what we call the space race for the interplanetary exploration, Africa has a particular history that brings to us what we call the very huge lessons of their self-organization fractal algorithms from some African tribes and the biomimicry. They are the best teachers for us in terms of space exploration, because if we look to the traditional houses in Africa, we are looking to very minimalist architectures. We are looking to the same approach of colonization of new places. And this is the same principle we are trying to use for the human and robotic exploration of other systems. Although we want to target the maximum comfort, the maximum technology on this kind of habitability systems, we need to step up to step down a little bit. We start by drafting some complex uh, um, uh, uh, contexts we developed not only modular but also integrated different habitability systems. We try to print them, we test some different techniques, but we realized that the best way for us to start is relying on what exists already. And what exists already and fits exactly with our habitability needs for this first step is the International Space Station with bigger module that would bring together the capability to have at least 3 persons on the same confined space, give them the capability to test, to work in lab, to eat, and to sleep in a medium long term duration. That is the ISS module, Columbus module. And this Columbus module was something that cost in terms of developing $2 billion, and that took a little bit of time to be developed. And we came up with a very more simple and first step approach. And we had also to study not only in terms of engineering, not only in terms of management, but also in terms of policy, how this model works, because we want to replicate all the dimensions, and you'll understand why.
All right, so since we want to replicate the full scope of a shared infrastructure scenario in outer space, this would necessarily include as well a policy component. And if we're looking at the Columbus module as a case study, then naturally the intergovernmental agreement would apply as the main governance framework in that regard as it pertains to the International Space Station. So of course, when we have a shared piece of infrastructure like the International Space Station, you can obviously assume and acknowledge and appreciate the fact that different components and different aspects of this infrastructure will belong to different countries. So this brings about a lot of different regulatory issues with regards to registration and importantly jurisdiction for certain aspects within the law. And it's important to have these clarified. So while we're going about the more technical aspects of the policy analog, it's also important to look at the regulatory side of this as well and sort of determine these rules, apply these rules, see how these systems work prior to such a mission. So some of the instances that we have focused on in this regard include registration, which is currently a very huge topic at the moment with regards to accountability and transparency in outer space. So what would occur in an instance where we have a module that has components from different countries, who then is responsible for registering each different component? Well, then in this regard, it would be the state of that owns the significant or the specific component in that regard, and that would be the European Union in this case, if we're speaking about the Columbus module. We also have the instance of criminal jurisdiction. So what would occur in the case of a crime that is committed in outer space within one of these modules, or at least in the policy analog within this bus carcass. And that crime would necessarily be ascribed to the country of the alleged offender, as would apply in international treaty laws currently in our terrestrial domain. And then another important aspect to consider is patents, since we are dealing with innovations, not only with regards to the components of the module, but also any inventions that are or that come about while astronauts are on the mission. So with this, it becomes quite particular to the country which has the jurisdiction over the module where the work was done. So for instance, if the invention is done within the Columbus module, it will necessarily be ascribed to the owner of that module, again, being the European Union. And then finally, we have civil liability. So with regards to civil liability, the rules here were a little bit, they were amended in the interests of promoting international cooperation. So understanding that everyone involved in such a joint venture has the interests of going to outer space successfully and sustainably, there is an acknowledgement that there isn't enough time to fret or worry about any or suing one another or any potential liability or damages in outer space. So there is a universal acceptance of risk. There is the acceptance that there is a certain amount of risk to be incurred. And for the sake of promoting that international cooperation, then it is in the parties' best interests to not resort to civil liability and to find other amicable ways of resolving their disputes, for instance, through consultations. So just to give you a little bit of insight into this intergovernmental agreement and how it especially speaks to the matter of risk, in Article 16, which is actually considered a fundamental principle, it assumes that risks are an inherent aspect of participation in ISS-related activities, and a party actually shall not make any claims against another party or against its related entities unless, of course, in very, very specific circumstances. So we see once again the whole notion of collaboration and shared access, and just promoting a space that is certain between the parties by establishing these rules ahead of time. And that is, again, is the same principle we are trying to establish with this analog research, which is, again, to establish these rules and provide a test bed for the rules in anticipation of this mission.
And as every single mission, we start by looking to all the dimensions, as I told. And first, we look for a landing place, a place to build and to start developing our analog. As the name says properly, we want to have similarity, biological, geological, and other environmental aspects to the planet that we want to simulate on that place. And in Angola, we have this lake arc of Tombua, where a few years ago we could find some oases and water, and this water disappeared, and we can now have the same conditions of soil, some geology, and some environmental similarities to the extreme conditions that we find in other planets. We can see that either temperature, relative humidity, the type of soil, they can allow scientists, students, analog astronauts to better understand how is to live on those kind of extreme conditions. And the Namibe is also good because it brings with this region together some abandoned infrastructures that also have some kind of design that brings together the inspiration of the space, science, and technology that also can be used, and we are preparing them to build what we call an African space museum. They are well located near the place, Arc of Tombo, where we're building the analog. And after that, we choose a place. We found that is the suitable place to test those extreme conditions in terms of environment. Now we need to come up with a model-based system engineering approach to design this kind of habitat, coming from the needs that is deliver habitability solutions, education, and research capabilities to the Namibe desert. We are going all the way to what are the principles of system engineering, from requirements until we have a functional concept that can be after that that can be organized and calculate, and we can calculate the budgets that will be needed, not only for launch in case of a real mission, but in case of an analog, we are talking about the representing of the launch constraints, the cost constraints, and the duration in terms of management. And project management is also an essential tool that we want to test, that we want to drill this path. We want to bring together what are the lessons learned from all the experience of the project management institution and Dinkosi through all those years, not only for the development of the analog, but also for the daily operation task management on that analog. And again, we will bring together all those three disciplines because those are the disciplines we are focused on, that we have background and either engineering, either project management, either space policy. We will use those knowledge to develop, but also to test those skills, those careers, and that knowledge inside the analog.
So, of course, owing to the fact that space law, especially with regards to human and robotic exploration, is still developing, there's necessarily a need to be quite creative in some of the policies that we would be applying. And in order to do that, we would base our policies off of analogous regimes that have arisen in international law. And I'll give a few examples of some of these different regimes that inform some fundamental principles with regards to shared infrastructure. And that would be, firstly, Antarctica, which is a very common one, very well known for the non-appropriation principle, which would apply in cases of safety zones in extraplanetary exploration. And this would have the policy effect of limiting resource extraction in certain zones, whether it be a cultural heritage site or for other reasons. We also have the example of the high seas and the international treaty law related thereto. And the high seas are treated as a res communis, that is a zone that belongs to all humankind. And of course, there would be obligations of registration and jurisdiction and generally accountability, seeing as it is a shared space to which there needs to be a certain level of transparency in that regard. So that would necessarily be an important policy point as well. And then the issue of, or rather the aspect of the commons, which emphasizes this notion of a shared resource, would translate into some kind of policy relating to collective management, that is the collective management of resources, of infrastructure, of information gathered from these extraplanetary missions as well. And then finally, a nice example is the transcontinental railroad development, which really speaks to the need for infrastructure sharing and also the participation of the private sector. So government, of course, would have to stimulate some sort of collaboration through public-private partnerships. And this would necessarily be a new space component to our policy as well. Other examples that unfortunately we wouldn't have time to go through today, but would necessarily encompass our broader policy framework would be, for instance, a human space flight legislation simulation, which would seek to, among other things, categorize different kinds of humans on space flights, for instance, whether it's a tourist or it's a private astronaut or a government astronaut, for instance, and what kind of rules would apply to them. And of course, the usual application of the existing treaty laws, and of course, new developing commercial laws which are applicable in outer space, such as patent laws relating to collaborations, etc. Yes, I think that is all for that point.
Yeah, and these can come together in what we call those 7 phases, where we first started until now with the survey and applying the concept of fundraising to get this first step, that is the bus. Then the requalification of the abandoned carcass bus. Then training of trainees to give local people the capability to maintain and protect this kind of infrastructure that is also for them to don't impact the local ecosystem. And then start the communication awareness of stakeholders. You have this training cycle of 90 days and 4 classes per cycle, then the evaluation and the resilience process. Here is one example of what we have done with the support of the bus center, the startup that works on the requalification of abandoned bus. They started that transformed one of the bus in a school, 7 meters of the bus center startup transformed in a classroom, and the 3 remaining meters are for a library. And we want to do the same taking this approach of the International Space Station Columbus module, because after we qualify it, it will be a very good place to help students working on radio amateur antennas, renewable energies, aquaponic systems, robotics, and all those systems. But in terms of use of the volume of the module, we use it almost the same approach to give not only the comfort, but also to make them live. And we see now that is necessary to live confined in this little volume. And we divided in the wet areas, dormitory, storage, leisure, and all the usage of an habitable module, not only to scale it down, to scale it up after the analog development, but also to give the opportunity to interface with all the systems we are trying to develop in terms of robotics, not only for transportation, for manufacturing, but also for integration and teleoperation. We want you to come up with us and so we can rise together as it's the head of this Mars Convention. We want you to rise together with us so we can solve the habitability problems, not only in Angola, then but in Zimbabwe, in Africa, because the possibility to solve this issue will bring with it the capability to bring also STEM, space STEM for everyone in Africa, to build research capability on the region, and to make Africa integrate or increase its level of integration on the international space exploration ecosystem, and boost more and more careers on the space domain, because an Analogue is a place where we can send astronauts and space professionals without leaving Earth. We thank you everyone that joined us and could stay with us until the end. We'll now leave the floor to you in case you have any doubt, any contribution, or in case you have any concern. I hope that you enjoy it. Danielle, the floor is
Great.
yours.
Thank you guys so much. We're gonna go ahead and do an open mic for the question. So if anyone has a question, you can feel free to unmute yourself and go ahead and ask.
Okay.
First, I wanted to say,
this is Adam. I'm wondering how many African countries will come and participate with you?
As many as we can. So the idea is, and is one of the articles we are also presenting here in the Mars Convention, we're making the assessment of what is the state of the art of Africa in terms of interplanetary space exploration. So the idea is to deliver first on the region, because if you can deliver this capability to Angola, and that's why we came with Angola and Zimbabwe as a test bed, but not test bed only in terms of infrastructure, but we brought here the model-based system engineering, the project management, and the space law, so we can make this approach replicable. If you have an approach standardized, if you have an approach well-defined, every single country that has an abandoned bus can use the same approach because all the models are there delivered with the program. But so far in Namibia, if we start with one bus, even for sustainability reasons, for sure we want to receive as many countries, not only in Africa, as many countries around the world as we can, not only to give them this possibility. You see all the analogs are around the world. they are available. We have here a very good example that Professor Julio and Engineer David, they are developing their analog site in Brazil, but they receive people from all around the world. I don't know if I answer your question, but please, if I don't, just ask it again and I will try to do my best.
Yeah, that was nice. And I think this would be a good thing for African unity.
Thank you. Thank you very much.
I would like to say,
Yes,
hello?
yes,
Yeah, go ahead.
yes, Mr. Marcos.
Yes, I just want to say that this is awesome. And I would love to learn more information on how we could be involved in helping this become to fruition.
Yes, thank you very much, Mr. Marcos. I apologize for not having here our contacts, but we'll share on the chat so we can reach out. And for sure, I took notes from your names. So even on social media, I'll try to find Mr. Marcos and send here our contacts so we can enter in so we can interact. And it will be a pleasure to share, because that's the main goal.
Thank you. Best wishes.
This is David Haslam. I'm a member of the volunteer group for the conference. I want to contact both of you because 2 years ago I almost got a job in Zambia, setting up a school that we were going to simulate a Mars base at the school, because I was going to be in charge of the educational part of that particular school. And I convinced the director of the school that we should do a high-tech, constantly running simulation, starting from 2nd grade up to 8th grade. So we'd have 6 years of the kids at the school, and they start with low-level basic stuff, and by the time they left at 8th grade, they'd be running missions, simulated missions, as if they're on Mars or en route to Mars. The financing was what finally fell through with the project, but I'm still in touch with the director. They've slowed the whole process down, and that's why I didn't go. But we did a lot of research. We spent about 6 months researching it, planning, doing lesson plans, doing all sorts of things to put the thing together. So I'd be very interested in contacting both of you. I've sent a personal message to both of you. If you can let me know your email addresses, I can contact you later and we can talk more about it. But I'm going to contact the director again and see if she's still interested in putting the whole thing together. And there's another note of interest. It was going to be an all-girls school because, you know, Zambia is one of the poorest countries in the world, and women are treated really badly there as well. And this was an opportunity to push them, push the girls and the women as far forward as we could in that country and into the world environment as a whole. So that's what we had set the goal for. So, and great presentation. I loved it. Very good.
Thank you very much. And you can, sorry, Olimbo, sorry.
No, I was just saying thank you. Thank you so much for those comments. Very good ideas.
Yes, you can totally count on us. We are working on several projects in terms of space education, not only the analog side, development of comic books, nano satellites, and if it's possible, if you have time, we are jumping right after to the other presentation. I don't know if we are late or not, but we are jumping right after to the other presentation, and we will talk more at the African level on how those things are in terms of space exploration. But totally count on us. We'll share it for sure.
Yeah, I was really looking for, when I saw the whole schedule, I was really looking forward to these two presentations because I spent so much time researching the
David, we're
project in
actually
Africa.
running out of time right now, but if you guys want to keep this conversation going, we can definitely start a channel on Slack, on the Mars Society's Slack channel. If you guys want to exchange information or allow other people to exchange and talk about this project. And we want to thank you guys so much for joining us today on this call. This has been a really unique and interesting lecture that you guys did today. So thank you.
Thank you
Thank you so
very
much
much.
for having us.